Okay, here are the basics you need to know about transformations for the final. We're going to take this triangle ABC, and the first thing we're going to do is reflect it about the x-axis. When you reflect it about the x-axis, the y-coordinate of every point changes to its opposite. So I see that the point B is at negative 6, 4. That means that its image will be at negative 6, negative 4. There, I finally got it. Okay, so I'm going to call that B prime. Alright, A is at negative 6, positive 2, so it's going to change to negative 6, negative 2. Having trouble making this work here. There we go. That's A prime. And finally, C is at negative 2, positive 2. It goes to negative 2, negative 2. Alrighty. And there we've done the reflection. Took me a little longer than I'd hoped. We call the new points the image points A prime, B prime, C prime, although we can call them anything we want. And each one of them are congruent to the respect. AB is congruent to A prime, B prime, etc., all the way around the triangle. The new image is congruent to the original. Okay, now we're going to reflect this guy about the y-axis. Okay, to do that, we keep the x, we just keep the y's the same, but change the x's to their opposites. So I see that A in the original is at negative 6, positive 2. Now it's going to be at positive 6, positive 2. Okay, the point C is at negative 2, positive 2. Now it goes to positive 2, positive 2. The x's are just changing to their opposites. Okay, and lastly, B is at negative 6, positive 4. Now it's going to be at positive 6, positive 4. There's my B prime, and make my triangle. Okay. The last one we're going to do with this is we're going to reflect it about the origin. When you reflect about the origin, both the x and the y's change to their opposites. So C is at negative 2, positive 2. Now it goes positive 2, negative 2. A is at negative 6, positive 2. Now it's at positive 6, negative 2. And B is at negative 6, positive 4. Now it's going to be at positive 6 and negative 4. Draw your triangle, and now you've reflected it all three ways. Okay, on this guy we're going to reflect about the line y equals x. Okay, well, y equals x, you don't really have to draw. It's a 45-degree line. It goes through points like 1, 1, 2, 2, 3, 3, 4, 4, etc. Okay, that's an ugly y equals x there. When you reflect about y equals x, the coordinates just switch. AB turns into BA. So for instance, A has coordinates negative 6, positive 2. Its image then will be positive 6, negative 2. Both change to their opposite, so positive 6, negative 2. And I've just done that one wrong. Oops. Let's start that one over. Sorry, guys. When we reflect about y equals x, the coordinates, as I tried to say, do in fact just switch, but I didn't switch them. This is now going to be 2, negative 6. They just literally just change. So I go 2, and then I go 6 down. And there someday will be my, there we go, there is my A prime. Okay, B right now is at -6, +4, so B prime will be 4, -6. So 4 over and 6 down. Okay, and C is at -2, 2, so C prime will be at 2, -2. 2 over, 2 down, C prime, and draw my triangle. Okay. This next one, translating, is easy. You're just going to follow the rule. And the rule down there, it says you're going to increase all the x's by 4 and subtract 2 from the y's. So you got this A, and again it's at -6, +2. So to get to A prime, the rule says add 4 to the x, so now I'm at -2, and subtract 2 from the y, so I'm at 0. So -2, 0, right here, right there, is my A prime. Okay, B is at -6, 4. So the rule says add 4 to the x, so B prime will be -2, and subtract 2 from the y, so 4 minus 2 is 2. B prime will be at 2, -2, +2. So it's going to crash with this guy here. Okay. And C prime, well, C was at -2, 2. And that, Dr. Gary, no, we're okay. All right. So C was at -2, 2. And that means we're going to put C prime. We're going to add 4, so that's going to be 6. No, sorry, it's good. -2, 2. So we're going to add 4, and that will be +2, and subtract 2 from y, that will be 0. So now I'm over here at 2, 0. Well, hope it goes smoother for you than it did for me there. But there's your translation. Let's see if we can do the next one a little bit better. Okay, we're going to do two things on this next guy. We're going to rotate him 90 degrees clockwise, and we're also going to dilate him about the origin, and I can't see, it's a scale factor of 1.5. Okay, let's take care of the rotation. It's pretty easy. What you're literally going to do is just turn your paper 90 degrees to the right, and then write down your new coordinates. I've already done it here on my next slide, so I'm just going to write down my new coordinates. My A prime now would be, it's over 2 and up 6, so that's 2, 6. My B prime is, it's over 4 and up 6. And my C prime, it's over 2 and up 2. So those are the coordinates that I'm going to carry back after I turn this thing right side up. And I'm taking just a second to write them down here. Okay, so after we've written them down, we're going back to the picture we were in, and I wrote down A prime was 2, 6, that's over 2 and up 6. B prime was 4, 6. And C prime was 2, 2. And here we've done our rotation 90 degrees to the right. Okay, our last guy is to dilate about the origin. And we're using a scale factor of 1.5. Well, what that means is, to get my new points, A currently is at -6, 2. For A prime, I'm going to multiply each of those numbers by 1.5. That's going to make the x-coordinate. That's going to make the x-coordinate -9 and the y-coordinate 3. Okay, -9, 3 right here. It's probably going to overlap with our other guy. That's okay. So there's my A prime. My current B is at -6, 4. So that means that my B prime, if I multiply each of those by 1.5, will be -9, 6. So -9 and then up 6 puts it there. And C prime. C currently is at -2, -2, +2. That means that C prime is going to be -3, +3. So if I go -3 and +3, -3, +3, I'm right here. Okay. And there we go. And what we have is our new guy's a little bit bigger than our original. In fact, he's 1.5 times bigger. He is similar to the original. The only time you get a congruent situation with a dilation is when your scale factor is 1. Otherwise, a dilation does not preserve congruence. It's the only one of these guys that does not. Well, I hope that helps. Sorry for all the little troubles I had going through. But if you can do these, then you know everything you need to know for the final exam and for a quiz that we're going to take this Friday.